Hi everyone, this is Dr. Feng Tian from Governor State University. Today we will talk about some general normal distribution problems. The focus of this section will be the connection between standard normal distribution and a general normal distribution. What is the relationship? More important is we will introduce how to use the standard normal distribution table to solve a general normal distribution problem. Now we all know standardized normal distribution is also known as the Z distribution. This is a special normal distribution where the mean is 0 and the standard deviation is 1. The important part of standardized normal distribution is standardized normal distribution actually comes with a standard normal distribution table. Sometimes it's called a Z table. Now, Z table can help us to find the corresponding probability for any given Z value. Basically, if we have the standard normal distribution table, we can find all probability for a standardized normal distribution. Well, if this is the only thing the standard normal distribution table can be used, then the standardized normal distribution won't be that useful because it's just one special normal distribution. So why it is more important and why do we need to spend so much time on it? But the most important part is standardized normal distribution or Z distribution has a special relationship with any general normal distribution. If you remember, the empirical rule of normal distribution basically tells us about 68% of the variable actually is located within one standard deviation from the mean. And similarly, 95% of all variable values actually falls within 2 standard deviations from the mean. And 99.7% of all x actually fall within 3 standard deviations away from the mean. Now be careful here is the measurement is what? The measurement is only, well, the range, how many standard deviation away from the mean. It doesn't matter what is the specified value of the mean and the standard deviation. So this is the general rule. It doesn't matter what is the shape of the normal distribution curve. As long as we have the mean and the standard deviation, this empirical rule always stands. So basically that tells us, well, actually all normal distributions, they have some similarity. If we use the mean and the standard deviation to do the measurement, actually these two are the same. Basically, the normal distribution can be any shape, but any single normal distribution with any mean and standard deviation combination, it can be transformed into the standardized normal distribution. Well, if we want to make the animation, we can think that the standardized normal distribution is a model. It has some scale, but it is a model. And this model can be enlarged and transformed into any real object. So the standardized normal distribution, we can do some transformation and transform it into any normal distribution. And this actually makes the link between a general normal distribution and a standardized normal distribution. And this link is, well, if we measure the distance between the value of the random variable and its mean by the standard deviation, then we can derive the same probability. So for example, these are two normal distribution curves. The first one is a general normal distribution with the mean equal to 100 and standard deviation equal to 50. The second is a standardized normal distribution where the mean is 0 and sigma is 1. But if we scale them by using the standard deviation, now we see $200 is above 100, and it is $100 more than the mean. And this $100 more can be measured as 2 standard deviation. Now here, if you recall the empirical rule, actually the empirical rule means as long as it is 2 standard deviation above the mean. Now for the z distribution, 2 is 2 standard deviation above the mean. Then the probability actually will be the same. So this actually tells us we can do a little bit of transformation. We can transform a general normal distribution to the standardized normal distribution, which means we can transform the value x from a general normal distribution to z value of the standardized normal distribution. The transform can be performed by subtract from the value of the random variable by its mean, and then divide the result by the standard deviation, which will give us the z value. So the physical meaning of z value now we can explain it as, well, the z value basically stands for how many standard deviation away the value x is from the mean. Now again, see, remember z value can be positive and can be negative. We know standard deviation is the square root of the variance, which is always positive. So basically the numerator here, x minus mu, will determine the sign of the z. If x, the random variable, is greater than mean, which means the value is above the mean, then the numerator will be positive. Then we get a z value that is positive. If the random variable has a value that is smaller than the mean, then the numerator will be negative, which will lead to a negative z value, which is just as we explained earlier. For the z distribution, well, all the z value above the mean, which is 0 in the standardized normal distribution, any value above the mean will be positive, and any value below the mean is negative. Now, given such a formula or such a relationship, now we can apply the standard normal distribution table and use it to solve a general normal distribution problem. Let's take a look at one example. Now, the studies show that the time it takes to download an image file from the internet follows a normal distribution with a mean equals to 8 seconds and the standard deviation is 5 seconds. So what is the probability that the download time is less than 8.6 seconds? So if we let x denote the download time, what we need to find is px less than 8.6. So what is the probability that x is less than 8.6? Now, we do the transformation. Basically, we can find the corresponding z value. Z equals to x minus mu divided by sigma gives us 8.6 minus 8 divided by 5 equals to 0.12. So what does it mean? It means this 8.6 is 0.12 standard deviation above the mean, which is 8. Now, this transformation actually links together the general normal distribution with the standard normal distribution. So originally we are looking at the general normal distribution where we are looking at the probability that x is less than 8.6. And actually the connection or transformation shows this probability on the left side, x less than 8.6, actually is the same as the probability in a standard normal distribution where the probability z is less than 0.12. So these two probabilities are exactly the same. So even we don't have a general normal distribution table to find the probability of the left side, actually we can use the standard normal distribution table to find the probability of the right chart here. As long as we have the right side, we know that the left side probability is the same. Now, from the standardized normal distribution table, we can find corresponding to the z equals to 0.12 1, 2, the probability is 0.5678. So this is the probability that the z value is less than 0.12. And because the left side probability is the probability we are looking for, we know for our normal distribution, the probability x is less than 0.8 is equals to probability that z is less than 0.12, which gives us the probability 0.5478. So the probability that the download time is no more than or is less than 8 seconds is 0.5478. Now, let's take a look at a follow-up question. Now we are looking for the probability that download time is more than 8.6. So what we need to find is the probability that x is greater than 8.6. Now we have the formula here. We see the total probability at the end of the curve is 1. And we are looking at the 8.6 corresponds to a z value equals 0.12. And we know the probability table, the normal distribution table, gives us a probability on the left side, but we're looking for the probability that x is greater than 8.6, not less than. But we know the total is 1, so we can use 1 subtract the left side value to get the right side value. So probability x greater than 8.6 equals to the probability z greater than 0.12. It equals to 1 minus probability z is less than 0.12. Eventually, it gives us a probability of 0.4522. So for a general normal distribution probability, if we're looking for the probability x is in between two values, we can always do the transformation to get the corresponding z value range. And as long as we got the z value range, we can use the standard normal distribution table to find the probability. So let's take a look at an example. We're looking at the same probability distribution. And here we're looking for the probability that the download time is between 6 and 8.6 seconds. Now, suppose x is a random variable. The probability we're looking for is p x is greater than 6 and less than 8.6. Now we can calculate the two z value, corresponding z value. 6 corresponding to a z value of negative 0.4 and 8.6 corresponding to a z value of 0.12. Now probability x is between 6 and 8.6 equals to the probability that z is between negative 0.4 and 0.12. So this is what the relationship between general normal distribution and a standardized normal distribution tells us. Given this information, well, it is easy to go ahead to find the result. We use a standardized normal distribution table. First, we found the probability that z is less than 0.12 equals to 0.5478. Next, we found the probability that z is less than negative 0.4, which equals to 0.3446. And next, we know probability that x greater than 6 and less than 8.6 equals to probability z is greater than negative 0.4 and less than 0.12, which equals to the probability z is less than 0.12 minus the probability z is less than negative 0.4, which gives us a result of 0.2032, which will be the answer. Which means for our problem, the probability that the download time is between 6 seconds and 8.6 seconds is 0.2032. Now, sometimes the question may be different from what we have demonstrated through examples. Well, let's take a look at an example. Let x represent the time it takes to download an image file from the internet. Now suppose x is normal with a mean equals 8 and standard deviation equals to 5, both in seconds. Now we are asked to find x such that 20% of download times are less than x. So here, first we know the distribution. The distribution is normal distribution with a mean equals to 8 and standard deviation equals to 5. But now, we're not given any time and try to find a probability. We're given a probability which is 20%. And we are trying to find the corresponding x. So we know this is less than a given number. And the probability that download time is less than this given number is 20%. But we are required to find this x, or the x is unknown. How to find this problem? How to find the answer of this problem? Now first, again, let's take a look at a standard normal distribution table. We know that standard normal distribution table, we have two areas. The first column and the first row give us z value, and everything in the middle give us a probability. Previously, we only learned, given the z value, we know we located the z value from first column and first row first, and we can go ahead and find the corresponding probability. This will be the probability that the z value is smaller than a given z value. But actually, since both of the value of z and the probability are given, sometimes we can find the probability from the table in the middle first, and then find the corresponding z, which will answer the question we just raised. For example, we are asked to find the question pz less than a number, but this probability is 0.9. So we try to locate from the middle the probability 0.9. This is the value we try to find because this is the probability. We found all the way here we cannot find 0.9, but 0.8997 is the closest value to 0.9. So we'll just use this number. And this number corresponds to two values on the first column and first row, which give us 1.28, which means the probability that z is less than 1.28 is 0.8997. So since we use the 0.8997 to approximate our 0.9, so 1.28 is the value we are looking for, because 1.28 will give us approximately 90% of the probability. So this is the other way to use the standard normal distribution table, where we found the given probability from the middle first and use this value to locate the corresponding z value. And of course, once we got the z value, we can easily transform it into a general x. So remember that previously the relationship between the random variable x and z value is x minus mu divided sigma equals to z. Now here we can move the denominator sigma to left side and also move the mean to left side, which gives us x equals to mu plus z times sigma, where z is the one that we can locate from the standard normal distribution table with the given probability. And mu and sigma are the two parameters defines the population distribution. So the steps to find the x value for a known probability is, first, we need to find the z value from the known probability, which is what we just performed through the example, how to use the given probability to find the corresponding z value from the table. And then we convert the z value to the x unit using this formula, x equals to mu plus z times sigma. Now back to our question. We are looking for a probability. We are looking for a value that 20% of all the download time is less than this value. Now, 20%, we look at the standard normal distribution table. We cannot find 20%, but the closest one is 0.2005. So we use this value to approximate the 0.2. And this value corresponding to a z-value equals to negative 0.84. Negative 0.84. Which means the probability that a z-value is less than negative 0.84 is about 0.2. So we have the z-value here is negative 0.84. Now we need to take further step to convert it to the x, which is x equals to mu plus z times sigma. Mu is the population mean, which is 8. Sigma is the population standard deviation, which is 5. We substitute these two values into the formula, which gave us a value of 3.8. So 20% of the download time will be less than 3.8 seconds.